Hey Garrett, your mom told me you were sick. I'm sorry you're not feeling well. So since you're sick, we're going to do a video tutorial over your homework. So hopefully this will help you stay caught up. So let's go ahead and get started with question 1. So on question 1, we are looking at solving the equation 2/3 parentheses 2x minus 1 plus 2 1/3 is equal to 7.5x. So the first thing we're going to do is we're going to do the distributive property of 2/3. So I'm going to multiply this, and 2/3 times 2 is going to be 4/3. So we have 4/3 x minus, and then 2/3 times 1 is 2/3. And then we just copy the rest of the equation down. So the next step would be to combine like terms on one side. So there's only one x, so we're going to leave the 4/3 x alone, and you could rewrite that as 1 1/3, but I'm going to leave it as 4/3 for right now. And then minus 2/3 and plus 2 1/3. These are like terms because they're both plain numbers. So we have to think of this really as 2 1/3 minus 2/3. And since you cannot subtract 1/3 minus 2/3, you're going to need to borrow from the whole. That makes that a 1, and then you're going to add 3 to this because 3/3 is a whole. So it's like you're adding 3/3 because that's one whole. So that would be 4/3. So 4/3 minus 2/3 is 2/3, and then you have one whole. So we're going to write this as now plus 1 2/3 is equal to 7 plus a half x. And so now I'm going to combine my x's, but what I notice about these two x's is they have different denominators. When I go to actually solving this and subtracting the half x from both sides, you realize that they don't have common denominators, so we need to come up with a common denominator. So if we think of 4/3 and we think of a half, we know that 6 would be the least common multiple for 2 and 3. And so we would do 2 times 3 to get 6, so 1 times 3 would give me 3, so this would be 3/6. 3 times 2 is 6, so 4 times 2 is 8. So we have to think of this really as 8/6 and minus 3/6. So that would give us 5/6 x, and then we would leave plus the 1 2/3 equals 7. So now we're going to subtract the 1 2/3 from both sides. So these will cancel out. You have 5 and 6x equals, but there's nothing here to subtract from 2/3, so we need to make a fraction. So we're going to have to borrow and make this a 6, and then this becomes 3/3, because if you think of 6 plus 3/3 would be 7. So 3/3 minus 2/3 is 1/3. 6 minus 1 is 5. And I'm actually going to add another slide so we can finish this problem because it's going to take a little more space. So on the last slide we got to this point. So next we have to think of dividing by 5/6 and dividing by 5/6 to find x. So really what we're doing is saying that x is equal to 5 1/3 divided by 5/6. And if you remember about fractions that we want to change mixed numbers into improper. So to make mixed numbers improper, I call it the check mark. You're going to do 5 times 3, and then you're going to add the 1. So 5 times 3 is 15, plus 1 is 16. So you have 16/3. So I'm going to rewrite this as x equals 16/3. And then we learn in 6th, 7th grade that you can multiply by the reciprocal. So then we would need to do 16 times 6, which if we come over to the side, 16 times 6, you have 36, and that would be 96. So this is going to equal 96, and 3 times 5 we know is 15. So then we have to determine how many times will 15 go into 96. So I know 9 would be too many. Let's check it. No, 8 won't work either. So I like to try numbers and see if it'll work. 7 should work. Let's see, 7. Oh no, 7's too much as well, because that would give me 3. So 6. 6 times 5 is 30, carry your 3, which is exactly 90. So then you would say it goes in there 6 holes, and you have 6/15 left. And you could even simplify that further. I don't know how big of a deal they make simplifying. So 3 goes into both of them, which would be 2/5. Okay, that problem was hard. I double checked it with an equation solver just to make sure I didn't make any mistakes, and it was right. So if this is something you're struggling with, is the rational numbers, because Ms. Kearney did say a lot of students struggled with that on the test, let me know and we'll practice that next time I'm over. But oh my goodness, that was hard. Let's go on to question 2. Question 2 and 3 are going to go together, and this is actually what they've been working on while you've been absent. This is called a system. It's where you have more than one equation and you're trying to find out if there's a solution that they both have that is the same. So the first thing we're going to do is graph the following, but as you can see, the second one is not in y equals mx plus b, which is our slope-intercept form. So we are going to need to change the 2x plus 3y equals 9 into slope into y equals mx plus b. So our first step is going to be to remove the x and remove it to both sides. These will cancel. You'll be left with 3y equals 9 minus 2x. I'm going to flip that on the next thing. And then if you divide by 3 and divide this entire side by 3, you have y equals, and then it's going to be negative 2/3 x plus 3. And now it's in y equals mx plus b form. So then we are going to, I'm going to put this as 0. I'm going to count mine as 1s since we're just going to 9, 6, 7, 8, 9, 10, etc. Same thing here. I just like to label mine just to make sure I'm on the right place. 7. Okay. So the first thing, remember, is your beginning, the b in y equals mx plus b, which in this first is a 3. And I'm going to do them in 2 different colors. So this one I'm going to do in blue. So this 3 would start here, and then 2x as a slope. So if the slope is 2, for it to be rise over run, we put it over 1. So it's going to go rise 2, 1, 2, and then it's going to run 1, and we're going to put a dot right there. So our first dot's going to go here, and then we're going to keep doing the same thing. And I recommend going through the entire graph for this because we don't know where these two are going to connect. Okay, and then we will make a line for this. So the line is going to go pretty much right there. Okay, and then always put an arrow at the end because the line continues for this. Okay, I'm going to do the second one that we created down here in red. So this one is also starting at 3. Okay. But it is going down to 1, 2, and 3. 1, 2, 3. So you're only going to be able to graph 2 points on this one because there's nowhere else for it to go, and they didn't give a really good graph. But I'm trying to find my line. There would be the line, and it would just keep going in that direction. So what does it say about the solution? So solution would be an answer. So the answer, because they both started at 0, 3, the solution set would be the same for both of them because that is where, at this point, would be where they both have, have the same set of solutions. Like they would both work out correctly. And this, we'll work on this as well, talking about what a solution set is and what it means. Okay, so I may teach you something new. I'm not sure if Miss Jensen has taught this to you, but so in this problem it says a limo service charges $105 plus 25 cents per mile. So if you think about your y equals mx plus b, your rate of change in this one is going to be the 25 cents x plus 105. So our beginning is already a super high number, so it wouldn't make sense for us to count by ones and so on. So what I'm going to actually do is what we call breaking the graph. So the point here is 0, but then I'm going to put a squiggly over here, and I am going to start at 105. Because anything below 105 is not going to matter. It's called breaking the graph because it means the pattern below this point is not going to be the same as the pattern above. And the next thing what I'm going to do to make this easy to graph is I think about how many quarters make $5, because I can count by $5 up, and then I can count across as well that way. So if you think of like 25 cents and that 4 quarters, like 4 times 25 is $1, but we need to get to $5, that this is times 5, so we would need to do times 20, because 4 times 5 would be 20. So 20 times 25 cents would give us $5. So the reason I say this is because we're going to want to count, and what you might also do, you could count by tens and just write down every other one. You could do 20 and then 40, once again, so you're not crowded, because I'm 60, and then do 80, let's see, 100, I'm actually going to write this way, 120, then 140, and then I would just stop there. So same thing on this side, so you can skip count. You can count for 5s, but instead of doing, instead of going 105, 110, you could skip count and just do every 10, or if you want to fit it in there, like 110, 115, 120, 125, 130, or once again, you could skip count and do that, like go to 110 and then do every other. So 135, 140, and then I'm going to just skip because these are really close. 150, that'd be 155, 160, 165, 170. And so this would be your miles, and this would be the cost to rent the limo. So then if you make a table, which is the easiest way to graph points for this, and think about, so at 0 miles, you're paying 105. So your first point is going to be that 105. And then I would go, well, we know for 20, that would be $5 more, so that's 110. So then go to your 20 is 110. And then if you go 40, that's 20 more, so that's 115. Okay, and then it's going to do the same pattern, and once you see the pattern, you can easily just graph it. So the thing that a lot of students miss is when they have to come up with what to count by. And so I suggest, think about the real world. You're not going to sit there and only drive a limo for a mile, but there may be people that are driving the limo for 20 miles or 40 miles or so on. So that's why I chose to count by 20s. One, because I wanted to just go up by $5. And so that might help you, and we'll work. This is something that I know my students took a lot of time in 8th grade to figure out, was what do I count my graph by? Okay, so I was looking at this question, and I'm actually like kind of confused because the thermometer and then the labels don't match. And so I'm just going to go over both answers, and I guess you could put both. But it says the highest temperature is 20 degrees, even though the thermometer could really go up to 25. So if the highest temperature is 20, and then the lowest temperature they're saying is -3. The way I tell my students to think about this is you have to get to 0 in between there. To get from 20 to 0, that's 20. And then to go 3 more, that's another 3. So the entire distance would be 23 degrees difference, if that's what they want you to use. Or if they're wanting you to use the 25 to -25, you would say that's a 50 degrees different. But I'm going to guess they're going with this. Okay, question 6. So we have 4 3D graphs. So we go on the x4 and then up to the 3. So let me make sure I'm on 4. 1, 2, 3, 4. Yes, 1, 2, 3 is 1 point, and then -2, 3. So -2 up 3, 1, 2, 3. -2, 1, -1. So that would be here, and 4, -1. So obviously this makes a rectangle. And so to find the area of a rectangle, we need to know our length times our width. And so this would be 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6. So we have 4 times 6. And so our area would be 24 units squared. And you need this label. I take off so many points, even with my 6th graders, when they do not label. Okay, question 7. So we are going to rewrite in slope-intercept form, which we know is the y equals mx plus b. I feel like we're getting really good at this. So our first step is to get the x to the other side. So if it's negative, we're going to add it to both sides. Cancel that out. You have 7y equals 7x minus 49. And then we need to divide by 7 to get y by itself. And so y equals 1x, or just x, minus 7. So it could be this, or it could just be y equals x minus 7. Both are correct. Okay, so I'm going to say this is Marissa is going for a run. After 20 minutes, she has run 1.5 miles. After 2 hours, she has run 7 25/100ths of a mile. What is Marissa's speed? So this is going to be where you're finding that rate of change. So I would think about your x and your y, thinking of as a table. So if you say in 20 minutes, she ran 1.5 miles, and then but change your hours to minutes. So in 120 minutes, because 2 hours is 1 hour 60, she ran the 7 25/100ths. If you think about finding the change, so this went up by 100 minutes. So in 100 minutes, and then think about how much did this, so if I did 7 25 minus 1.5, so you have 5, borrow, 12 minus 5 is 7, 6 minus 1 is 5. So she can run 5 miles and 75/100ths in 100 minutes. So if we take that down to 10 minutes, because we need to get to 60 minutes to get it to miles per hour. So in 10 minutes, that would be dividing by 10. So dividing this by 10 would make it would just move your decimal place. So it would be 575 thousandths. And then we're trying to get to 60 minutes to get 1 hour. So that would be times 6. And then we would also multiply this by 6. So we would say 575 thousandths times 6, so you get 30. 42 plus that is 45, and then 30 plus that is 34. You have 3 places behind the decimal, so she would run 3 45/100ths miles per hour would be her speed. So that was a Man, these problems were intense this week. Of course, when I'm not there. We have finally made it to the last question. So this one we're just solving again, and as you can tell, they're really working on those decimals and fractions. So once again, I like to put my x's on the left. It doesn't matter where you put them, I just always start there. So I'm going to minus this 8/100 from both sides. Okay, this will cancel, but you need to think of this 0.10 as actually, or the 1/10 as having a 0. I'm actually going to move it up here. So think of it as 10 minus 8, which would give you the 2/100 x minus, and then we're going to rewrite this decimal equals the 134 thousandths. So we're going to add the 6 thousandths to this one. These will cancel, and we are left with the 2/100 x is equal to, and then that would be 10, 4, 1, bring your decimal down. And then if you divide this, so remember when you're dividing decimals, a lot of people forget that you have to move the decimal out. So by moving it, if I move this 1, 2, so it's gone, 1, 2, so it's gone, then I also have to move this 1, 2. So really what we have is 14 divided by 2, which actually makes it really easy. So x is 7. Hopefully this wasn't too much for you, because that was a pretty intense weekly practice. But I hope you start feeling better, and then hopefully I can catch you up over break so that you are ready to go when we get back from Thanksgiving break. So feel better, and hopefully I'll see you soon.